All right, hello. In this video, we're going to review what we have learned so far in our biochemistry unit, reviewing kind of what we should have already learned from chemistry a while back, reviewing that kind of stuff, and then talking about the properties of water. So, first of all, let's review what atoms are. Remember, atoms are the smallest basic unit of matter. And so atoms are all usually made up of certain subatomic particles. So the first thing is all atoms have a nucleus, which is kind of their center core part. And inside the nucleus, there are protons, which are positive particles, and neutrons that are neutral. So both of those are inside the atom. And then there's this other particle that's rotating on the outside of the nucleus called the electrons. And electrons have a negative charge. And electrons have to do with bonding. And the protons and neutrons just stay in the nucleus. But the electrons are the ones that are rotating and are having to deal with bonding. Now, an atom on, let's say, on the periodic table, those atoms are stable. What makes them stable is that the proton number, the positive protons, are going to be the same number as the electrons. So if you see helium here, helium has 2 protons and 2 electrons. So it's balanced and it's neutral. The whole atom itself is. All right, so then we're going to be looking at the difference between elements and compounds. Now, the elements of life, I want you to try to remember, is called CHNOPS. That's how we're going to remember it. It's CHNOPS. That's a fun little way of saying it. And so these are the atoms or elements that are important to life. So C stands for carbon, H stands for hydrogen, N stands for nitrogen, O stands for oxygen, P stands for phosphorus, and S stands for sulfur. So you can see on the periodic table, these are the elements of life, and they're very important. They're called CHNOPS, and they are rearranged. They are bonded together in varieties of different ways to make compounds that are important to life. And we're going to be learning about, in this unit, the macromolecules. So how carbon, hydrogens, and nitrogens, and oxygens, and phosphorus, and sulfurs bond together in different ways to make really important molecules for our body. So we're going to be learning about those later on in the unit. All right, so let's talk about how atoms are bonded. So we learned about and reviewed about 2 types of bonds, ionic bonds and covalent bonds. So pause for a second and see if you can answer this question. Which one is which? Which electrons are sharing when they're bonding? Which atoms are sharing electrons? Ionic or covalent? Which one do you think? The answer is covalent. Covalent bonds. Co is a root word on our root word list that means together. So think of the electrons together are sharing. Now in ionic bonding, they're not sharing electrons. They're either giving their electrons away or they're taking the electrons. So they're either giving or taking. And then that develops a charge on the atoms, which is called ions. And then that charge is what actually attracts the bonds together. All right, so let's review the properties of water. So water has some really unique characteristics to make water so awesome. So have you ever counted how many drops it takes for water to bubble on a penny before the water kind of spills over? You notice there's like a big bubble you see in this picture right here, kind of a big large bubble staying together. Well, that's because water has a property called cohesion. Co, again, is root word meaning together. So cohesion means that water likes to stick with water. Water likes to stick to other water molecules together. So together they like to stick together. Water loves water. So water has the property called cohesion. Water also has a property called adhesion. And add is a root word you need to know, which means to or toward. So think of water also likes to stick to other elements or atoms or other things. So if you notice right here that sometimes that water can kind of slightly hang over the side of the penny, it's because the water not only likes to stick to itself, but it also likes to stick to the penny. So water also likes to stick to other things, and that's called adhesion. All right, so we had this big word called polar or polarity, and that's a really big deal with water. The reason why water is so cohesion and adhesion, the reason why they are like that is because water is polar. And what that means is that the electrons aren't being shared equally between hydrogen and oxygen. So there becomes a slight charge to it. So if you look here, this is a picture of water, which is 1 oxygen and 2 hydrogens. And hydrogen is sharing its electron with oxygen, and oxygen sharing its electron with hydrogen. But here's the deal. Oxygen hogs the electrons. All the electrons like to be around oxygen. So because there's all this negative electrons around oxygen, it makes oxygen have a slight negative charge. And because all of the negative electrons are toward oxygen, it makes hydrogen have all the positive parts. So it makes them slightly have this charge to it. So oxygen has a slight negative and hydrogens have a slight positive. So when they're bonding with things, and they're bonding with each other, they're bonding because of the charge that it has. And that's why water is kind of the universal solvent. It can dissolve a lot of variety of different things because of polarity, because it can dissolve just regular neutral things, and it can also dissolve things that have charges. For example, water can dissolve sugar, which is a neutral element or compound, and then water can dissolve salt, which are ions that have charges, and they can pull those ions apart. So solvent would be the water, is what does the dissolving. If you put something into the water, that's what we call the solute, and that is something that is going to be dissolved into water. Now, a solution, you should remember, is something that all of the solute dissolves equally and it all spread out. So like Kool-Aid is a solution. Sugar is a solution. If you have something that doesn't dissolve, like oil, or like, let's say, do you guys ever have Italian dressing and you shake up the Italian dressing and it kind of mixes up, but then it settles down at the bottom? That's called a suspension. So you have a solution, which everything's mixed up and dissolved, and then you have a suspension that's not. So those are some properties of water. So let's go through and review in your slide. This was slide 12 and kind of answering those questions as review. So it says, how many atoms are in one water molecule? And the answer would be, how many bonds are in one water molecule? And that would have been 2. This is, what are these bonds called? Well, those bonds are called covalent bonds. They're sharing electrons. They're not sharing equally, but they are sharing electrons. So then over here it says, water molecules are very polar. So the oxygen atom attracts its shared electrons strongly. So the oxygen atom is going to be slightly negative. And then each hydrogen atom, electrons are attracted away from it by the pull of the oxygen. So hydrogen atoms are slightly positive. And then this makes the atom all stick together to have a strong attraction. So water sticking to water. Which one was that? Cohesion or adhesion? Do you remember? It would be cohesion, water sticking to water. Adhesion is when water sticks to something else. And then these atoms are sharing the electrons unevenly. So when we say they're sharing unevenly, when we call it a polar covalent bond, which because that's water is polar. So on the next slide, you were supposed to draw a picture. So here's my picture, and I kind of zoomed in and made like a cartoon picture just to show you, because water has covalent bonds and also has hydrogen bonds. So let me explain. Oxygen and hydrogen right here are covalently bonded. They're sharing electrons. So that makes oxygen a slight negative and hydrogen a slight positive. Now a hydrogen bond is the dotted lines you can see here between hydrogen and oxygen. And so that's water molecule bonding to another water molecule. And now those are through hydrogen bonds. And what that means is now they're being attracted by their charge. So this water molecule with this negative charge is attracted to this positive charged hydrogen, and that's how water is bonded together. All right, so what you're going to do next is you're going to take your formative atom and water assessment, and then you're going to start working on the next part of the interactive notebook, which is talking about those macromolecules I was talking about that are important to life. There's 4 of them that we're going to learn about in this unit.